Alright, in this video we're going to look at the second test, sketching parabolas using factorization. Same test conditions, 30 minutes, you're allowed your calculator, but no notes, 5 multiple choice questions and the rest a short answer. I'm going to answer most of these questions without the CAS calculator, but just also realize that a lot of them can be answered with the CAS calculator. So question 1, a parabola has x-intercepts at -3, 0 and 4, 0. Which one of the following equations could not represent this parabola? All right, when you have it in factored form, remember you can easily see what your x-intercepts are. So we basically say, all right, that means x plus 3 equals 0 or x minus 4 equals 0. So your x-intercepts are at x equals -3 and x equals 4. So that one is represents that parabola. So does this one here, because it's just the other way around. And I just realized before, because I've actually started this video, C also represents that, D also represents that parabola. So your correct answer is not D. I'll just do D before I do C. So when we factorize D, we get y equals, now you need two numbers when multiplied give you -12 and when added give you -1. So that's, let me just go back, x minus 4, x plus 3. Okay, so you can see that's the same as the first two. And then let's just quickly look at option C. When I factorize that, I get x plus 4, x minus 3. And I've just realized then that I had the incorrect answer, so I'm going to have to make those changes. All right, question 2. Which one of these parabolas is symmetrical about the line x equals 2? And as you can notice there, I've got two answers. Okay, so symmetrical about the line x equals 2. Remember, symmetry has it cut in half. Now, when you have it in factorized form, and I might just get rid of that parabola for the time being, and draw the x-axis. So here we have an x-intercept at 1 and at 3. Now your turning point is halfway between these two values. So what value is halfway between these two? It's the number 2. So your parabola, no matter how it's drawn, or that should have gone through 2, has an x-intercept of 1, x-intercept of 3, and the halfway point is 2. So that's why A is an answer. Looking at B, your value of h is -2, so this is symmetrical around the line x equals -2. For question C, h is +2, so you also have it symmetrical for this equation as well. And then D, let's just draw that. So you have now an x-intercept at -3 and -1. So your halfway point is -2. So this one is symmetrical around -2. It looks something like that. So there's two answers for that one. All right, looking at question 3, which of these parabolas has one x-intercept? So needing to know what is happening, this one here is sitting on the line. Okay, so it has a value of k which is 0, so it's not moving, neither moving up or down. This one here has an x-intercept at -4 and 4. This one has two x-intercepts as well. And this one here, just trying to think off the top of my head, I think it has no x-intercepts, but you can also graph it and see what it looks like. If you were doing it without your calculator, because you can't find two numbers when multiplied give you 4 and when added give you 16. So you would do completing the square for that one. And I might just do it because some of you might be interested. So we add half of 16, which is 8, and then square it. So 64 minus 64. Actually, no, we'll have two x-intercepts, sorry. So then we have x plus 8 squared minus 68. Yeah, so we have two x-intercepts also for D. So A is the only one with one x-intercept. Just before I move on, if you're sitting there thinking, how do I know there's two x-intercepts here? we have a positive parabola that's been shifted down 68. So your parabola, here's your x-axis, and it's been down here, it's at -8, -68. Okay, so can't emphasize enough getting your equation into turning point form to see actually what's happening with your parabola. All right, let's move on now to question 4. The graph of y equals x squared plus bx plus c has x-intercepts at -1, 0 and 5, 0. What are the values of b and c? So based on these x-intercepts, you can get it into factorized form. Now, this is working backwards, and I've just done a video on this, so hopefully you understand what I am saying. So these are your factors. When we've got x plus 1 equals 0, that's where the -1 comes from, and x minus 5 equals 0 will give you an x-intercept of 5. So I've written it in factorized form. There's no coefficient here, so I don't need to put an a here. Okay, so there's no unknown. It's already 1, so I don't need to calculate what it would be here. All right, so just expanding these brackets, and I get b equals -4 and c equals -5. All right, for question 5, for the parabola with the equation y equals x squared minus 8x plus c, for what values of c will this parabola have only one x-intercept? Okay, if you've got one x-intercept, it means it's a perfect square. And don't get perfect square and the difference of perfect squares mixed up. So a perfect square just means x plus a squared. Okay, so just some number here. So to do that, you just need to complete the square. So if I've got x squared minus 8x, I take the coefficient of the x and divide it by 2 and square it. So half of -8 is -4, squared is 16. And then we can, we don't need to do anything else because we're just completing the square here basically. So for it to be a perfect square, c has to be 16. And just so I can prove that I'm right, this becomes x minus 4 squared. All right, moving now to question B, or part B, sorry. Sketch the graph of each of the following, showing the y-intercept, any x-intercepts, and the turning point. So you could, if you like, put these into turning point form, but you can still find the turning point, and I'll show you how to get the turning point when you've got the x-intercept. So here we have an x-intercept at -3 and 3, and your turning point is always the halfway. So you could add them together, then divide them by 2 to figure out what that is. So -3 plus 3 is 0, divided by 2 is still 0. So your, let's just do the turning point here. It's at x equals 0. So to get your y coordinate, we just substitute in x equals 0. So we have 3 times -3, which is -9. And you can see here that's also going to be our y-intercept. Okay, so there's -9 there. So we've got our y-intercept, our 2 x-intercepts, and our turning point. So do make sure you actually state them as well. You could graph that on your calculator. There's nothing that says you have to do it by hand, but remember you can't always rely on your calculator because you might not be able to use it. Okay, for this one here, first of all, factorize it. So I can easily factorize that. I don't need to complete the square. So this one becomes y equals, what do we got? -5 and -1. Okay, so remember you need two numbers when multiplied give you 5. So -5 times -1 gives you 5. And when you add them together, you need to get -6. Okay, so my x-intercepts are at 1 and 5. Now, just like we did before, your halfway point will give you the x-intercept, x-coordinate of the turning point. So add them together. 1 plus 5 is 6. 6 divided by 2. So there you are at 3. So your x-coordinate of your turning point is at x equals 3. Now to get your y-coordinate, just substitute it in. So we got y equals 3 minus 5 times 3 minus 1. 3 minus 5 is negative 2 times 3 minus 1 is 2. So is that y equals negative 4? And you can see I've done that here. Your y-intercept, just let x equal 0. So we have negative 5 times negative 1 gives you positive 5. But you can also see here it's your constant. So you can use either your factorized equation or your expanded equation to get that. You could also, if you wanted to, complete the square here to get it into turning point form to find the turning point. But I think it's a lot easier just to, it's not necessarily easier, it's just a shorter way of doing it by factorizing. You don't always have to complete the square. All right, let's move on to C. So this one here is like an invisible K here. You don't have to put in plus 0, but it does help. So you have a negative parabola. Turning point is at negative 2, 0. So you can see that is here. And that's also your x-intercept. Your y-intercept, just let x equal 0. So that's at negative 4. And when you're drawing it, you do need another point. So what you can say is, well, how did I get this point? I went across 2, down 4. So if I do the same on the other side, across 2, down 4, there's your other point there. Okay, because remember your parabolas are symmetrical. And if you feel like it, you can draw a nice little face there. Yeah. All right, let's move on. All right, question 2. The equations of the following graphs are in the form y equals x plus a, x plus b. For each graph, find a and b, and then determine the coordinates of the turning point. So we kind of did this before. All right, so I can see we have an x-intercept here at negative 2 and an x-intercept here at 4. So that means your values of a are 2 and negative 4. And your turning point is halfway between them. So when we add 2 and negative 4 together, we get 2, and then divided by 2 we get 1. So your x-coordinate of your turning point is at 1. So that's why I've got x equals 1 here. So you can see it's even halfway. And then just substitute that in. So you can see it should be around negative 9, if not negative 9. But when we substitute it in, we actually prove that it is negative 9. You can also do that on your calculator. So if you had a bit of trouble doing it by hand, you can also do that on your calculator. All right, this one here, we have x-coordinate at 0 and 5. So I've substituted those values in to get the equation. Your turning point is halfway, so 0 plus negative, oh, did I draw this one incorrectly? I think I did. No, what did I do wrong? Let me just pause for a sec. Sorry, I was looking at the wrong values of your x-intercept. So I was thinking x-intercept was negative 5. Your x-intercept here is at 5. So halfway between 0 and 5 is 2.5. I was adding the wrong values. Okay, so there we've got x equals 2.5. Substitute that into your equation, and then we're left with negative 6.25. And you can see that on the graph, there's 2.5, and then your y-coordinate is just past the 6. Okay, so you can always check on your graph whether you're correct. Those types of ones is a bit harder to do on your calculator. All right, and then last question. A parabola intersects the x-axis at negative 4, 0 and y 0, and the y-axis at 0, 12 to determine the equation. So you should be able to set up your parabola in factorized form. Then we substitute in the point 0, 12, and that's just to get the value of a. So when I do that, I get a equals negative 3, and then all I need to do is then substitute it back into here. So those types of questions were actually similar to some of the classroom worksheets that you had to do. Please make sure that if there's anything from the sheet that you don't understand, that you do ask for help, and good luck on your test. Bye-bye.